Hey there, Math 126 fans. Going to talk a quick 14.4 homework chat. 14.4 uses partial derivatives to find what are called tangent planes, a plane that just touches your surface at a point and contains all the tangent lines there. Ultimately, we have a few things we learned that we'll learn in lecture, which is that when you're given a surface of this form, f of x is the slope in the x direction, f of y is the slope in the y direction. From those we can get, this is more than you need, but I'm going to restate what we learned. From those you can get two vectors. These are tangent vectors in the x and y direction, and if you take their cross product, you get negative f of x, negative f of y, 1. So this is what we sometimes call an upward pointing normal vector for our surface. Now we don't talk about that really in any sort of detail in this class, but there's one homework question at the end that sort of requires you to think about that a little bit. So let me just say this and then I'll state the problem. So if you have a point here on the surface and you want a vector that points straight out of it, that's this vector, negative f of x, negative f of y, 1. If you want a vector that points in the x direction, that's this vector, 1, f of x, 0. And again, we'll talk about that in class. It's also in the text. And then the slope in the y direction is this, 1, 0, f of y. And their cross product is perpendicular to both. Together, they give you this plane. Now, the way we typically write the tangent plane, at a given point, this would give you the following for the tangent plane. X minus a minus f of y at AB, y minus a plus z minus whatever the value of the function is at that point equals 0. But the way that's typically written is the following. And then from here on out, you don't even have to think about those vectors I just wrote. This is the tangent plane. We think of it as the plane that approximates what's happening on the surface at that point. So that's the formula of this section. Sometimes we call this the linear approximation, the value you would get from this. Occasionally we like to have the z by itself. And when the book does that, they call it the linear approximation, but it doesn't mean you do anything different in terms of computing it. So sometimes this is called the linear approximation at x, y. Okay, so what does that mean for you in terms of the homework? And you should recognize that this first part looks exactly like a tangent line in 2D. This is the extension of that. Quite all of these homework questions are asking you to compute the partial derivatives and then plug in the values. So for example, this one that says z is the square root of xy, so I'd probably write it as x to the 1/2, y to the 1/2. I would take the partial with respect to x, which would be 1/2 x to the negative 1/2, y to the 1/2. I would take the partial with respect to y, which would be 1/2 x to the 1/2, y to the negative 1/2. I would plug in 6 and 6 to those. Probably it simplifies, so the z value is just 6. When you plug into this, you get 1/2, 1 over the square root of 6 times square root of 6. So I think you get a half. And when you plug into this, you also get a half. And now we are done. So you would write z minus 6, that's the z value. You do the slope in the x direction, which is a half. You would do, and we'll do examples like this in class, 1/2 y minus 6. And if you solve for z, you would get 6 plus 1/2 x minus 6 plus 1/2 x minus 6. And we would say that near 6, this is a decent approximation of the value of the function. Now that in itself, students always have lots of reasonable questions about that, like why would we approximate? We have a calculator. It's not really about approximating at a value, it's an analysis tool that we use all the time in science and in practice, where you take something that's hard to analyze and you replace it with something that is simpler to analyze. You lose precision, but you gain simplicity, and then you try to prove that the loss of precision doesn't change your argument that much. Huge idea. So the tangent plane is an example of that. We're going to return to this sort of idea of approximation at the last few weeks of the term. So that's all you're going to do. So if you still have questions about this is easy to ask about in the quiz section. Just go, or Math Study Center. It's mostly just compute the partial derivative, plug in, done. So you're going to do that a few times here in the homework. Question 2, you'll do the same. Question 3, you'll do the same. Question 4, you'll do the same. Question 5, you'll do the same. And then you have 2 conceptual questions, 6 and 7. So when you get to 6 and 7, I want to warn you, those are different. Those are like kind of a conceptual review of everything in chapter 14 so far. So I'm sure there will be discussion in chats about this. But 6 says, imagine you have a surface and you do not know the equation for it. But you do know 2 different paths that walk around it. One that walks like this and one that walks like this. And there's a point here where they meet. And the point where they meet is this point 3, 1, 4. And the question says, can you find the tangent plane? And you cannot use the formula because you don't know the surface. So you're back to square one. You need a point and a direction. So you need a vector that points straight out of that. That's the n. And you need the point. Well, we already have the point. And the point is 3, 1, 4. And so what we need is a normal vector. So there's your start for that question. How are you going to find that normal vector, given that all you know is 2 curves here? So it's an intersection question, so it would really be nice to know what the t is and what the u is when they intersect. But now you got to think about, can you find a couple tangent vectors from what they gave you, and can you find their cross product to fill these in? So that doesn't, it's a little, it does have to do with tangent planes, that's why it's in this section, but it's more a conceptual kind of review question. Question 7 is kind of more of the same in terms of conceptual review. It says, imagine you have some sort of 3D surface, and someone tells you what one of these numbers are. They fix this to be x equals 2. Well, the moment they fix it to be x equals 2, it's now just a 1 variable problem. So you can do the problem this way. Just make it a 1 variable problem. The question says, what is the tangent line for that? So now we're trying to find a line in 3D. So as I said, these are both kind of conceptual review questions. And that line needs to go through whatever point they're talking about, 2, 3, negative 16. And it needs to go in the direction of the tangent when y is your variable. So we would like to put 3 numbers here that basically would indicate the slope in the y direction at this point. Now earlier, this is what I meant by you might want to use one of these vectors. There's the slope in the x direction, there's the slope in the y direction. So these 2 questions we're asking you to think about the section and interpret. Now, when the question says enter a comma-separated list of equations, you are going to enter x equals 2 plus, and then you'll have a number, t, comma. So I've had a lot of students get this wrong just because they didn't follow the instructions. Because it says list of equations, it does have to have that equal sign. Because it says comma separated list, it does have to have that comma. Anyways, don't let that be the reason you miss it. I'm sure a lot of people won't watch this video and won't catch that. If you notice them asking questions on the discussion board, help me and answer their questions. All right, hope that helped.